All right, you've seen all those satisfying Gridfinity setups. Now it's time to make your own. In today's video, I want to take you from absolute zero, beginner, to then creating your own custom Gridfinity bin setup in Fusion, or using some alternative solutions to CAD, and then getting that sent to your 3D printer today. For those of you new to my channel, my name is Ty Ridings. I'm a mechanical engineer at a large aerospace company, but I like making these nice, concise tutorials to help take you and your projects from zero all the way up to where you need them to be in no time at all. So without further ado, let's jump into today's topic. All right, so to jump straight into it, what is Gridfinity? Gridfinity is a universally accepted bin system in the 3D printing / maker community based on a project that was developed by our very good friend Zach Friedman over at Voidstar Labs. The idea is pretty simple. There are bases that hold the bins, and the bins themselves that all follow a base 7mm standard for its dimensions. What makes this awesome is the enormous amount of open source files already available on all major 3D printing websites. I'll link a slew of my favorites below just to pick the bases and bins that work for you for now. I'll also link some Gridfinity generators towards the end of the video in case you finish this tutorial and are on a strict timeline to help build that gap on basic configurations while you put more effort into your specific customizations. Okay, so the very first thing we're going to want to do is download the extension itself, and do not worry, this is a pretty seamless process. Pop open Fusion, come up here to your utilities tab. We're going to go over here to the add-ins and then click the drop down, and we're going to go to the Fusion App Store. Now, once this pops up, we're going to go ahead and search Gridfinity generator, and boom, it pops up right there. And you'll notice that this is supported on two different types of OSs, Mac and Windows. So depending on what kind of operating system you are using, make sure to click that one. For me, I'm going to be using a Mac today, but again, fear not, this is very much so the same across both platforms. In fact, Mac is a little bit more complicated because of security. Once you've picked your operating system, go ahead and come up here under this little text that says free and click download. Now, fair warning, Autodesk, if you're not already signed in, you may have to sign into it. It's just the same username and password that you use to get onto the software itself. I'm going to go ahead and open up this package installer here in my downloads. I'm going to double click it, and boom, like I told you, Mac has to be special in its own way, and it's saying we cannot do this. If you are a Mac user, this is going to be very, very helpful. If you're not and you're running Windows, you should not have the same issue. Let me know in the comments if you do. You should just be able to open the installer and run it. I'll show you how to fix that while we're on the Mac. So I'm just going to hit done. I don't want to move it to the trash. And what you need to do is come up here to the little Apple icon up here in the top corner, click on system settings, navigate down to privacy and security. And then from here, scroll down until you see the little security section. And you'll notice right here, it says this package was blocked to protect your Mac. If this bothers you, I understand. Feel free to navigate away. You got to do what's best for you and your system. I'm going to hit open anyway. It's going to be like, are you sure? Yes, I'm sure. Open anyway. I'm going to go ahead and put in my password as an admin, and we're off to the races. Now, when the installer dialog pops up, you're going to click through it, and we're going to go ahead and hit install. Now, once the installation is complete, you go ahead and close out of this, move the package installer to the trash, and that's it. The next part is super easy. Close out of this window, go back into Fusion, and what we need to do is restart the program, and then it should enable your features to be used in a blank canvas. Now, I've restarted Fusion, and we can check to make sure those settings stayed. You can do that by coming up to the solid tab, and then there's a little drop down for create. We click that, and you'll notice at the very bottom of the drop down menu, you now have Gridfinity bin and Gridfinity Baseplate. You may also get a couple of icons tacked onto your toolbar up here. And don't worry, if you do not have these icons right now and you want them, you can come down, do the little three bubbles next to Gridfinity bin and hit pin to toolbar. There's just a little checkbox that you can click. And that's it. We're ready to start our project. First things first, I always like to save my project and my assembly to make sure that it is ready to go when I go to start making parts and have everything set up the way that I like to do it and a lot of people like to do it. It's always a good idea to set up a new project. Say you're turning this bin system into something specific like a drawer in your garage or something in your house. You can go ahead and make a new project up here to just start basically a top level folder that can start holding a bunch of different components and assemblies inside of it that are all geared at the same thing. If this is a little too in the weeds, that's okay. You may already just use a general folder that you save anything into, and that's totally fine. For this, I went ahead and created a Gridfinity tutorial project, and you'll see in here I already did a test piece just to make sure everything was persistent and worked the way I wanted it to. Next, we're going to go ahead and save our part before we start editing anything. So I come up here to save. I can make sure that I'm saving in the right location, which is my Gridfinity tutorial location, and I'll give it a name. We'll call it new Gridfinity tutorial. And now we are officially ready to go. For me, for today's case, I'm gonna go ahead and start with the base because I think that's the most important place to start. And there's some considerations that you should make. The most important thing is consider where you want to actually put these bins at, because the base is going to dictate how much space you're gonna have to set up your bin system and sort of organize it. And that'll also tell you how you need to divide up your grid structure, whether you're gonna do, 4x4 plates or 5x5 plates or 3x3 plates. It's really up to you. And that actually feeds into the second consideration, which is making sure that whatever size base you're making, if you're gonna 3D print it, is actually compatible with the size of your base plate as well. An easy way to do this, if you really want to, is sketching out maybe like a little feature or some kind of sketch that you can keep highlighted that is the dimension of your printer's bed to make sure that everything will fit on a build plate nicely. If you don't want to go that far and you know you're starting off with something small that is going to fit, which I'm going to do today, you can just go ahead and jump into making your base. To do that, we'll come up here to the Create tab. We'll go down to Gridfinity Baseplate, or you can just click on the icon if you have it up in your toolbar already. Go ahead and click it, and you'll notice right away you get this kind of intimidating parameters window that pops up that allows you to start making all the customizations to your box based on whatever you need it to do. So I will say this right away. Do not freak out when you see this. We're going to go through this section by section and make sure that it's digestible, at least enough to get you started with making a basic plate and set of bins to do what you need them to do. And most importantly, up here under the info drop down, there is a link to GitHub. This is super helpful. I highly recommend if you have a second and you want to jump into this to get a better understanding of everything on this page. This is a really helpful resource. It takes every single parameter that you can tweak and it gives a definition behind what it is, what it can do, and how to manipulate it accordingly for what you're going to need. When you start diving deeper into making these custom Gridfinity bins or these setups, this wiki page is super helpful, and it has a drop down for not only the base plate itself, but the bins as well. So this first section is your basic sizing. And like I said in the beginning of the video, everything is based on a 7mm unit system. So that's why you see these kind of wacky values for 4242. They're all just multiples of 7. For all intents and purposes today, I'm actually going to keep this basic sizing for two reasons. One, it's easy. There's really nothing else to that. Two, if you keep the kind of universally accepted base units, that enables you to put any other type of bin you may find on the internet directly into your model or into your design and not have to worry about making sure everything fits together. So I recommend staying with the base system if you can, but if you don't worry. This is where we actually start jumping into the specific modifications to start churning out the part that you want. I'm actually going to kind of get ahead of myself a little bit, but I think it's going to be helpful for you. And that is scrolling all the way to the bottom to the preview section here. And there's a little checkbox for show preview and it says slow. This is important to know because when you enable this, it will actually generate the part and then you will watch all of your updates kind of populate in real time. Depending on what kind of computer you're running or what system you're on, this could really bog down your model quite a bit. So you don't have to do this, but I found, especially when I'm making just the bins and really simple stuff, it's really helpful because I can see those live updates in real time and know if those are changes that I want to make. So I'm going to go ahead and click yes. And there we go. You can see I've already got a little base plate generated here. Now, scrolling back up here to the top, we get into our main dimensions. And right now it is set to a 2 width by 3 length unit grid setup right now. To show you what this does, if I bump this to 3, we're now in a 3x3. If I bump this down to 2, we're in a 3x2. This is where you can really get into customizing and planning out the size of the base frame that you want to start with. So to make it easy, I'm actually just going to stick with this 2x3 for now. Features is actually where things start to get really kind of cool. There's a ton of ways that you can configure your base. What you're looking at right now is the base plate type of light. There are 3 different modes. You can have light, you can have skeletonized, or you can have full. And all that really does is adds material depending on what you need to do. Specifically, if you want to add things like magnets or screws, depending on how you want to secure the bins to the base plate. Just to kind of demonstrate what this looks like, I'll go to skeletonized real quick, and I'm actually going to move my grid for a second so it's easier to see. Now, right now you can see I have magnet cutouts activated, which are these little holes up here. So I'm gonna go ahead and deactivate that, and I'm gonna deactivate screw holes real quick just to make this easy. Adding magnet cutouts is adding a little space where you can press fit or glue in a magnet. That way it will magnetically hold your bins down to the base plate if that's a feature that you want. Really handy for keeping them secure and not kind of bobbling all over the place depending on where this plate's gonna be at. You can set the diameter of the cutout and how much depth you want to the extrude to make sure you're matching the right dimensions for the magnets that you have, so you're not stuck with just one size. You can customize that however you want. Screw holes is another one. Say you want to screw these bins down to the base plate, you can actually populate some features to do that. So it's just a through hole, and then on the back side it's a little countersink. That way you can screw in from the bottom and attach the bins down to this base plate to make sure they never move, if that's a feature you want as well, to make sure that everything is staying locked into the grid. And once again, you can change the diameter of the screws through hole along with the head cutout diameter as well. This next feature is actually super helpful. Say you want to stick with this base 7 system, but whatever drawer you're putting it in, it doesn't divide up into the right units and you have a little bit of a gap between the edges of your total base plate system. You can actually add paddings on the side to make sure that you are getting that gap closed. So let's say here on this left side, that's going to be near the edge of a drawer or something like that, and you want to try and cover up that gap to make sure everything fits together. Well, you can do that. You just specify the amount of padding you want to add to that. You can do 2, you can do, let's see, 12, doesn't matter. All of this works the same. And what's really cool is this doesn't have to just apply to one side. Say you've got it in a corner, or say you want it to perfectly fit inside of some square box and all sides need to have a little bit of padding. Well, not a problem. You can just update your units on each side to put in the amount of gap that you need. And that way you can get the right fit for your part. Of all the features you can start with, the padding is great because you'll know right away when you go to make your base plate, it may not perfectly fit with the normal system or however you want to divide it. And this is an easy way to cover up that distance between the two. The next one, you can adjust the bottom thickness of your plate if you want to. So if you want your plate to go down or up a little bit, right now it's set to 6.4 between this bottom edge here basically and where the lip starts. You can tweak that too. If you need these raised up or lowered to a certain amount, you can totally update that as well. And you can change the clearance between the base plate and the bin itself. These are just a couple more features you can tweak. And then lastly, you've got connection holes. When I go ahead and toggle that on, you see all these holes populating around the sides of everything. And that's so that you can actually secure bases to each other. I know that was a lot. Features holds a ton of stuff. You're only going to need the things that are applicable to you for now. And to be honest with you, this light version is what I use the most because it does everything I need to do, especially inside of a drawer. And when I add a little padding to the sides to get that snug fit, I usually have no issues with setting up a base plate this way just to get started. This last little drop down is inputs. Say you change a lot of the parameters inside of this for your project and you don't want to have to redo that every time you make a new plate or you make a new bin. You can actually save all of those inputs as your new default set essentially. And that way, every time you activate the Gridfinity base plate, it will pop up all those parameters and keep you good to go. And don't fear, if you do that and you want to go back, you can always reset to your defaults that you had previously, or you can do a full-on factory reset just back to the very beginning that we're starting with right now and start from scratch if you need to. With that out of the way, I've got my 2x3 grid. I'm happy with that. That works for what I'm going to go through today. And then you just hit OK. You'll notice right away too, up here in your browser, you've already got a new component populated, all of the features inside of it for your base plate. And that is its own new standalone part inside of your browser tree. Now, a little behind the scenes here, if you're wondering how does this thing create all these features? Well, it just kind of runs a script and it populates everything based on the parameters you updated. And you'll see down here, your timeline just has these little 3 dots and a plus sign. That actually captured all of the design contents inside of it. So real quick, I'm going to expand this just so you can see. These are all of the features that got generated from what you put into those parameters, just to kind of see how the sausage is made behind the scenes. Not super applicable, you're just getting the part that you need. But if you're ever curious or you need to tweak little things manually, that's where you can go to do it. Building your CAD skills is just like building a model, layer by layer with the right foundation. That's where today's sponsor, Brilliant, comes in, with hands-on lessons that strengthen the problem-solving mindset you need for design and engineering. As your projects grow more complex, so should the way you think through problems. And that's what what Brilliant is all about. With thousands of interactive lessons across math, science, programming, data analysis, and even AI, Brilliant helps you strengthen your problem-solving foundation through hands-on exploration. Brilliant helps you master challenging topics through interactive problem solving, not just passive lectures. You'll learn faster, retain more, and actually enjoy the process. Their lessons are crafted by experts from places like Stanford, MIT, and Google, so you know you're building real, practical understanding. Brilliant's growing set of programming courses is designed to strengthen the core problem-solving habits behind great code. You'll learn Python, explore computer logic, and practice writing real programs that help you develop the mindset of a true programmer. To learn for free on Brilliant, go to brilliant.org/TyWritings, scan the QR code on screen, or click on the link in the description. Brilliant's also giving my viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. And now let's jump back into Gridfinity in Fusion. Next thing we want to do is make a bin or a set of bins that will fit inside of our baseplate. To do that, super simple, same process as with the baseplate itself. We go to the solids tab, click on the create dropdown, and we hit Gridfinity bin, or you can hit it up here in your toolbar as well. And same thing, it pops up a window that has a lot of the same characteristics that you had before with some minor tweaks that are meant for just bins themselves. Once again, you can pop over to the wiki if you need to get a deep dive on each parameter itself. We'll go ahead and start from the top. Basic sizes, I'm gonna leave that the same. I'm not gonna tweak it. I wanna make this so that it can universally accept any parts that I find on the internet and just stick with the current system that it has. One thing I do wanna note here though, this is actually called out in the wiki, is you want to make sure that your bin XY clearances is the same here as it was for the base plate that you generated. So make sure if you're making any changes to this in one model or the other, it needs to be the same between both for them to stay compatible. You'll see this in a minute under the features. The bin height is establishing what unit you want to use for incrementing your different sizes in your bin height itself. The bin height is just setting up a base unit. And again, it's going to stay 7 millimeters, just like the rest of the system, but this is something that you'll multiply to change your height up and down. This could get a little confusing, but I'll touch on that when we get to that in the features. Now, as I did last time, I'm going to go to the bottom. I'm going to go ahead and let the preview show of the bin itself. Here we are again back at dimensions. And right now it actually just set to the 2x3. I'll bring this up right now. It's the bin height, which is the Z direction coming up and down, is set to 5. Now, this does not mean 5 millimeters. This means 5 multiplied by 7, which is 35 millimeters. So the actual bin sidewall height itself is 35 millimeters because you set your base unit to 7. And I know, little confusing, and a way to bypass that, if you just want to get down to really specific millimeter increments, you can just set this to 1, and then whatever you toggle your bin height to down here will just be a 1-to-1 increment of that 1 millimeter. So if I didn't want to deal with the complexity of seeing these multiply, or if I cared, I could go ahead and change that. But for now, I'm going to leave it alone. Just know it's something that you can toggle. Also, if it's a little confusing, they kind of help you out with the math down here by showing width, length, and height. You'll notice it's not perfectly 35. That's because 35 is just the wall itself, basically starting from this edge up to the top of here. You've also got these little feet that populate down into the plate itself. So it's accounting for that extra, nearly 4 millimeters of clearance needed for the feet to go into the base plate too. That's why your total height is this. And again, apologies if that's kind of confusing. I figured I'd just try to give you enough to be dangerous and kind of tweak as you need to, but these are nice little reference measurements right here to know what's going on. We're getting into bin features, and this is where it gets actually kind of fun. This is where I think the majority of your customization is actually going to start, and your creativity can sort of run wild here. There's a couple different bin types here. There's hollow, there's shelled, which is basically hollow, but then it also has a grid system inside of it. And then there is also solid. So this will basically just generate a solid block. And for those of you wanting to make your own little custom cutouts for a specific tool or a specific set of tools, this is kind of the recommended path, so that you can either A, bring in that part and just cut it out of this existing body, or you can now use this top face as a sketch plane to sketch out whatever silhouette of the feature you're trying to extrude into, and go ahead and use that as kind of a block to mold out of with a sketch as well. So really cool. For now, I'm going to keep it hollow, just keep it simple. You've also got this generate lip for stackability. All this does is change the top part in case you want to be able to store another bin on top of this this one. If you don't, you just want a clean edge all the way around, totally fine, you can have that. But while you do have a lip generated, you can also put in lip notches. When I activate that, it actually makes these little cutouts that kind of help simulate partial features from the base grid in case you want to make like sub bins to stack on top of this lid and give it a little bit more stability to keep them from sliding. So for now, I'm going to keep it simple. I'm going to keep just the basic lip for stackability and go from there. Another really awesome section with bins is defining how many compartments and what kind of features you want those to have. Right now, you can see that I have this set to 1x1 grid bin width and length, but this is where it gets cool. You can toggle this by incrementing and making new channels inside of your bin for whatever kind of stuff you want to make. You can do this in both directions. Say I want to split it down the middle this way, I can do that. I can do a 2x2 so that I have 4 different compartments inside of here. I'm going to breeze over grid type real quick because this is where it actually gets a little complex. You can hit this drop down and select custom grid. And what that actually allows you to do is add in specific bin cutout positions to make multiple channels. And instead of doing this here in the CAD, I'm just going to jump to the wiki and give you a quick preview of what that looks like. If you come down here and start looking through what it is, you can start defining an index of places that you want bins or channels and remove references to anything else. So instead of just having to deal with a 5x5 bin, maybe you just want to have it divvied up into a couple different pockets inside of the overall body. Well, you can do that by defining those custom lengths and widths for specific sections inside of the bin to make your cutouts, which honestly, this is kind of nice, especially if you're wanting to kind of silhouette or shadow box a tool. This might be worth trying out instead of going through the complexity of trying to sketch out something that's really perfectly snug fit to kind of a weird or organically shaped part. You might be able to get away with just setting up a custom grid using those parameters to fit the function that you need your part to actually do. This is another cool section, which is your scoop and your tab. And let's say I actually want these to hold something like some fasteners. Well, as you might notice right away looking at this bin, as small as it kind of is, if I had this in a drawer with other hardware and I wanted to quickly be able to pull a little tiny fastener out of here, say I have like a bunch of M3s or something hanging out in here, it's going to be kind of a pain because you'll have to squeeze your fingers in there and try to pull it out. And this is where the scoop comes in super handy. If you activate this little checkbox, it makes a little scooping ramp so that if you have stuff inside of here, you can reach down and just scoop it up the ramp to pull it out. Super cool feature. I really like this, especially for little bits and bobs you might be wanting to make. And this pairs really nicely with the label tab. Say you have 4 different types of parts or, subsets of parts that you have divided up in here and you want to be able to recognize which one's which. You can activate the label tab. And what that does is makes this nice little overhang feature here. And this gives you a little place to either take a Sharpie and write down, like M1s, M2s, M3s, M4s, or if you have something like a label maker, you can pop little labels on here to tell you what's inside of each bin. And the 2 of these together is really, really nice to identify your part and then be able to pull it out and use it as needed, which I really like. So I'm actually going to keep this and just kind of pretend that we're making a part for a set of fasteners that I want to be able to store. And what's cool is that, now that I'm looking at it, I'm like, this seems like kind of a waste of space and the fasteners I want to separate are really small. Well, I can go ahead and bump that up or bump that down as needed, depending on whatever orientation I want them to be set at with my grid width and my grid length. So I'm actually going to make this a 2x3 just because I feel like I'm maximizing a little bit more storage here, and this will work perfectly for my set of fasteners. This last section, you'll recognize a lot of the features right away. And to make this a little more obvious, I'm going to remove my layout grid and I'm going to mute my base plate for a second just so we can see these things update in real time. Same thing if I had screw features on my base plate and I wanted to have holes to receive the fastener on this end as well, I can just activate the screw holes portion and it'll give me some nicely defined screw holes that will match up to the base plate dimensions really nicely. And I can change my screw hole diameter to make sure it fits with the type of screw that I want to use. I can add in magnet sockets in case I wanted this to magnetically attach to the base plate. And as you can see, it's already patterned and set to mate with the base plate portion really kindly. And again, you can set your cutout depth and diameter here as well. well. Another kind of cool part is this little magnetic socket tab. Say you want to be able to place this in there with glue, or be able to pop these in and out. This will just give you a nice little feature that helps with setting those magnets in there as well. I'm going pretty basic here. I don't need all this stuff. I just want to show it for demonstration purposes only and take it as it is right now. Looks good. Last thing, similar to our base plates, in case you set up a custom set of parameters that you want to keep persistent throughout the rest of whatever project you're working on, you can save that, you can reset them, or you can factory reset those as well, just the same as your base plate. Once you're happy with all the settings, make sure to double check everything, because I do want to warn you, once you set the settings and you hit OK, you cannot jump back into the Gridfinity bin extension to make adjustments. As far as I'm aware, I tried digging into this a little bit and I did not have any luck. If someone out there knows of something, please let me know. But once you hit OK, you are locked into your design for this compartment. And the only other way that I'm aware of being able to make any of these changes, if you really had to, was expanding your timeline down here for the design, which, as you can see for the bin, is way more complicated. But I just wanted to put that disclaimer out there in case you do something like that, and now that you're messing with the part, you're like, oh man, I didn't really want that. The one thing that I will say that is kind of handy, say you freshly just designed this part and hit OK, and then you notice something on it right away that you don't like. One easy thing you can do is actually just delete the part and restart the generator. And what's nice is it will keep all of the settings you just had active in the same session. And then from there, with a new part, you can go in and make the changes that you need to. That's the best workaround I have for now. Comment below if someone knows of a better way to jump back into the extension, but I've been having a hard time finding out a way to do that. I'll come back up here and activate my top level assembly and just kind of check out the part to make sure everything looks good. And we can go ahead and roll forward with our project. Now, these are just a couple of tips that I kind of like to do. You can skip this little short section, but these are things that I feel like are kind of nice when you're getting ready to export it. If you want to see what everything looks like, you can actually come up here to your Modify tab under Solid, Modify, and click Appearance. And you can actually drop in colors on your part to see if it's going to look roughly the way you want it to, depending on whatever you're planning on 3D printing these in. This is just kind of like a fun little thing to do to make sure everything looks kind of visually appealing the way you want it to. There's more settings that you can adjust, obviously, in your slicer, but for me, this is kind of a fun little thing to do. Another thing, this is kind of a basic thing to think about, but if you're at all worried about any clearances or heights or anything like that, don't forget you have your inspect tool up here. If you want to check, can't remember what I set the height to, you can go through and just check that maybe from here to here, and it'll tell you, oh, this is a 34.5 before that chamfer starts to kick in. I find this to be kind of a nice little thing to do before you export the design, just to make sure you're 100% comfortable with whatever you're about to send to your slicer and make. That's it. Last step, let's go ahead and send this to our 3D printer slicer just to get the part ready for manufacturing. What's really cool about this, and I'm going to be doing this with the Bambu Lab Studio since I own a couple of Bambu Labs printers, is I'm going to export both of these at the same time and open that directly inside of Bambu. So to do that, come over here to your top level part that includes both the base and the bin, right click it, come down here to save as mesh, and under preparation type, make sure you have print utility selected. And then for application, you can pick the slicer you want this to go to, which for me is going to be Bambu Studio. I'm going to use the 3MF format, and I'm going to go ahead and hit OK. And boom, there we have it. We popped our parts here into the slicer. And if you're unsure, you can move one out of the way, put one over here, one over here. So if you're feeling really crazy, you can print both of these together. You can set up your different build plates. You can send them to a couple of different printers at the same time to get mocked up. But it's a really seamless process in Fusion to take this part that you just created in whatever the 20 or so minutes that we were talking about it and get it sent to your printer so you can go ahead and slice it and send it off now. For this last little chapter, as promised, I do have another couple of resources if you still wish to bypass CAD altogether. Like I mentioned, you can pull these bins directly off the internet from Printables or Things or just the Gridfinity wiki. They're loaded with a ton of different types of bins, and you might be surprised by how many models people have already created to shadow box certain tools or perform certain functions for maybe a piece of hardware or something that you have. If you're in that camp and this feels like this is a little too much right now for what you're trying to do, definitely go check out the Printables website first and foremost, which you can see here at this gridfinity.xyz. Super easy to use. And if you click on the Gridfinity catalog and just start scrolling through it, you'll see there has been a ton of community support making these grids and bins and stuff like that are custom tailored and may already possess a solution that you need for yourself today that you can just download and take off with right away. Now, options 2 and 3 are a couple of Gridfinity generators. I didn't use these a ton, but I did see a lot of people saying they had good luck using these and they're really seamless and they're web-based. So if you're on an operating system that just gets too bogged down for Fusion or you're having a hard time just making the design, you can come in here and make yourself a custom box. And what's cool is that it's the same parameters that we were working with before, but you can tweak it just with dragging and dropping these little sliders over here on the left-hand side and kind of messing around with these in a little bit more user-friendly of a way, and then export it immediately out into an STL or a step file format that you can then just take off with and use. The other one is this gridfinity.perplexinglabs.com. It's basically the same as the other one that I showed you with a couple of different ways to kind of mess around with your bin. Feel free to check that one out as well. It's just another resource. Again, I haven't used it a ton, but I did find this when I was scouring the web. Hopefully all of these in combination are helpful enough between using Fusion and then just sourcing any different kind of model you can out there on the internet. I am hoping this video can be a one-stop shop to get you from where you are at right now to either find a custom solution that you can just drag in and drop to your setup or give you the power to be able to do this yourself. All right, thank you all for tuning in today. If you'd like to check out some more Fusion related content, please check out the videos that I'm gonna link here at the end screen. These are super helpful. I tried to consolidate big lists of stuff to help you fast track where you are with your Fusion and your CAD designing journey. So thanks again, and I'll see you next time.